Let's discuss about deletion in B tree. So before discussing about how to delete a value or shared values from B tree, we have some rules. Before moving to the rules, let us know about what is the meaning of in-order predecessor and in-order successor, because it will be used more often during the deletion of an element from the B tree. We are going to use the concept called in-order predecessor. Okay. So the largest key on the left child of a node is called the in-order predecessor. The largest key in left child of a node is called in-order predecessor. So during the deletion process in a B tree, we are going to use in-order predecessor. So please know what is the meaning of in-order predecessor. The largest key, if you are going to search in a left child of a node, that will be called as your in-order predecessor. The next is in-order successor. So it is the smallest key. It is the smallest key in right side of a node. Okay. So if you are going to find the smallest key in the right child of a node, it is called as in-order successor. And if a B tree is having order m, then maximum child will be your m. Maximum number of keys in each node will be m minus 1. Minimum child node will be how much? That is seal of m by 2, and minimum keys that should be present in each node, that is seal of m by 2 minus 1. Alright. So these are things you need to keep in your mind at the time of designing a B tree and deleting a value from the B tree. So that property should be maintained. We can keep maximum m number of children. We can keep maximum m minus 1 keys in each node. We can create m by 2 its seal value for minimum number of children in each node, and minimum keys that can be present in each node will be seal of m by 2 minus 1. If you are going to delete element from leaf node, delete a value from leaf node. So the case one is that if the leaf node is having case 1, the situation may arise that if you want to delete a value from the leaf node and that leaf node contains more than minimum number of keys. If leaf node contains more than minimum keys, then directly delete the key. Directly delete the key. There is no issue. You can delete the key if the leaf node contains more than the minimum key. Case 2. The leaf node contains, if leaf node contains exactly minimum number of key, minimum size of keys, then borrow, then you have to borrow from left sibling or right sibling, or right sibling, whichever contains more keys from left to right order. For example, suppose I am having a B tree of order 3, aim is 3. So we can keep maximum 2 number of keys. So I placed here 100 and I placed one more values 200. Now it points to one leaf node, this points to, let's say, another leaf node. Suppose I am having the value 50 here, 70 here, alright, and here I am having the value in between 100 to 200, 1 and 0, 150, okay, and this node contains 250 and 270. Suppose. Now, suppose I want to, for case 1, suppose I want to delete 150. So, if the leaf node contains more than minimum cage, so order 3 means minimum cage will how much? 3 by 2 minus 1, so 1. So, it contains how many values? It contains 2 values. So, I can directly delete this one. There is no problem. We can directly delete. So, minimum key will be how much? 3 by 2, it's a seal value, minus 1. So, 1.5 seal is 2 minus 1 is 1. So, ultimately, if leaf node contains more than minimum value, yes, it contains 2 keys, so more than 1 key, so we can directly delete it. So, direct delete 150, there is no issue. You can directly delete the 150 value. If you are going to have a B tree, just think about a case 2, we are having 100 here we are having 200 here, and this points to okay. Let's say it is 50, it is your 70, it is your 150, and this is 250. Now just think about, if I ask you that delete 150, so your second leaf node contains 150, but how many keys present in this leaf node? 1. So it's at, if the order is 3, then minimum keys should be 1. Here only one value is there, so I cannot directly delete 150. So I will take the help of left sibling or the right sibling. So the left sibling contains your 2 values and the right sibling contains 1 value. So whichever contains more values, so that will be helpful to delete this 150. What should you do? You transfer this 72 here and this 100 to here, then you delete 150. Now the tree will look like this way. So what will happen? So 150 deleted, 100 comes to here, and 70 is now transferred to here. Now you can see that 70's left value is 50. So 50 is root, no, your parent contains 70 and 200. 70's right child contains your 100, and 200's right child contains your 250. So this is the way you are going to delete 150 from your leaf node. If the leaf node contains exactly the minimum size, we need to take the borrow from the left sibling or the right sibling, whichever contains more keys from the left to right order. Case 3. If left and right, if left and right sibling contains exactly minimum keys, then what should do? Then merge with left or right sibling through parent. Then merge left or right sibling with parent. For example, take an example. Here I am having a node which contains 28 and 33. Okay. Here is one node. Here is also one node. Here is also one node. And this node contains 25. This node contains 30. This node contains, let's say, 40. Now if you are going to delete 40, so let's say 30, you are going to delete 30. So 30 is present in this leaf node, and which contains the minimum key. It contains only one key. I cannot directly delete this 30. I can take the help of the left sibling because it contains one value. I cannot take the help of a right sibling because it also contains one value. So in that case, what should I do? If both the left right sibling contains exactly minimum key, then mod the left or right sibling. So I may go for the merging with the left sibling with the parent. So I can merge this one. You are going to merge, then your tree will look like this way, 33. Okay. After merging, one node will be created. After merging, one node will be created. So what the value will be? So here, so I will keep 25 and 30. 30 will be deleted, and then what is plus here. So this is the way. So parent value is 28. So 25, 28 became the left child of 33 and the right child remain as it is. So this is the way we can delete 30 if left sibling and right sibling cannot provide the borrow facility. Deletion from internal node of a B tree. So the first case is the case 1. I can say that the internal node which is to be deleted is replaced in Inorder Reducer. The internal node which is to be deleted is replaced by Inorder Reducer. I told you what is the Inorder Reducer. That is the maximum value of left child node. Inorder Reducer or Inorder successor. Inorder successor. If a right child contains more keys with respect to minimum key size. If right child contains more number of keys as compared to minimum your size of the keys, then we'll take the Inorder Reducer. Otherwise, we'll check that your Inorder Reducer size. If it is more than the minimum key size, we will take the maximum value from the left child. For example, so the order of 3 B tree, suppose 100 is here, where you have placed left as 50 and another is 70, right as your 150 and 200, okay. You can say that 10 and 40 is placed here. Here 55 and 65, and here let's say that 90 is placed. Similarly, we have some values here and here also. Okay, some values are there. Some values are here. Now it is asked you that delete 70. Delete 70. So 70 is present in internal node. I cannot directly delete this one. So I will take either Inorder Reducer or Inorder Successor. So Inorder Reducer means left child. So 70's left child is 55 and 60, which contains your two kids, and right child of 70 contains one child. So your left child node contains more than your minimum kids. So I will take the help of your Inorder Reducer here. So which one will be the maximum value? Inorder Reducer means the maximum key. So 55 and 65, maximum 65. So 65 will move to your 70 place. So what I can do here, I will write here 100. Okay, then the left part is 50, then your 65. All right, and the right part is here as it is 150 and 200, and 50's left child is 10 and 40. Okay, and 50 and 65, in between there is a child node which contains your 55, and then 65 right child will be 90, and other nodes are here also as it is, we kept it. Alright, whatever maybe nodes are there, we just kept it. Now you can see that one. So 70 is deleted. So how do you delete it? So I have deleted by taking the help of your Inorder Reducer value. So 65 jumped to your 70, then 70 is deleted, then 65 is placed in the place of 70 as a, so 65 right child will be the previous right child value. So case 2 is that if both left and right child contains minimum cage, then what should you? Here your left child contains more than minimum cage, right child contains exactly minimum size key. So that's why we took the help from the left child. But if the both left and right child contains the minimum cage, so what should do? So in that case, you need to merge. You need to merge left child and right child. Right child. Okay, for example, so let's take an example of this B tree which is having order as m equal to 3, and the question is given delete your value 50, delete the value 50. Now 50 is present on the left with 100, yes, it is there. Now I cannot delete the value 50 directly because it is present in the internal node. So in that case, what should you do? You will take the left sibling help on the right sibling, left child and the right child help, or borrow from the left child and the right child, but left and right child contains exactly minimum key. So in that case, what we do? We have to merge the values. We should go for the merging. So here we'll apply the merging operation. We need to go for the merge. If you will go for the merging, then how it will look like? So 100 will be here, then I can write here 100, its value will be 75 left value, okay, and the right value is 150, and here 20 and 60 gets 20 and 60 they are merged, okay, and 75 right value is 80, so I kept there, I kept as it is, and 150 left value is 125, 125 and 150 is right value is 200. So there is no issue. Now we can say that in the new B tree, so the 50 is deleted. So how do you delete it? Here the borrow facility is not available from the left and right child, so I need to merge that one. So that is the, if you are going to delete the from the internal node, if such situation arise, then we'll go for the merging of left and the right child. So case 3, the internal node value that will be deleted contains minimum key size. Then merging with sibling through parents. For example, take one example. Suppose I am having here 20 here. Okay. 20. Left side value is 15. Right side value is 45. And 15's left value is 5. Right value is let's say that 18. And 45 left value is 30. And 45's right value is let's say that 50. Now it is given delete 15. So now just look at the 15 is present in the internal node. 2 is present in the internal node. I cannot directly delete the internal value 15 because it contains the minimum size, but in this case it contains 2 keys. If I am going to delete, then if I am going to delete 50, then another value is there, 75 is there. So in that case I can go for the merging of left and right children. But here the problem is different. Here the internal value that you are going to delete, it contains only one value. The internal node contains only one value. So I cannot go for merging of 5 and 18. If you are going to merge it, it is not going to have any parent node value, because people deleted means the parent information will be deleted completely. So in that case I will merge the sibling of 15. 15 sibling is 45 through parent. Parent is 20. So what should I do here? I will merge a 20, the parent value, with the sibling value 45. Then 20's left child will be merge value 5 and 18, and 45's left value is 30, just I kept as it is, and 45's right value is 50. So that is the meaning of the case 3. If the internal node contains the minimum keys and you want to delete that minimum key, then you need to go for the merging with the sibling. Whenever you are going to apply your deletion, so there are possibilities. You may delete from the leaf node or you may delete from the internal node. If you are going to delete from the leaf node, we have some cases you need to take care. If you are going to delete from the internal node, we have some cases we need to take care. So these are the rules you need to follow at the time of deletion a value from the B tree. Let's go for a complete example. So let's take one complete example where you're going to apply all the rules of deletion from B tree. So what is given to you? Delete 210, 170, 220 from given B tree of order 5, let's say, of order 5. Now just think about what are the values you want to delete: 170, 210, 170 and 220. And the order of tree is given 5. So now M is your 5. Then maximum keys I can place in each node will be 5 minus 1, that is 4. That will be 4. Okay. And minimum key I can place, that will be 5 by 2, take the seal, minus 1, which is how much? 2. Right. Then maximum child will be 5, minimum child will be 3, minimum children will be 3, because 5 by 2 its seal value is 3. So now take in this example, if I am going to delete the 210, the first value that I want to delete, that is a 210. So 210 is greater than 115, so I went to right side. So right side is 210, so again 210 is greater than 200, so I went to right side. So I got here 210. So this leaf node contains 210, so I can delete the value from the leaf node provided the leaf node contains more than minimum keys. What is the minimum key size? That is 2. It contains how many? 4. So it is more than minimum values. I can delete 210 directly. So that is the my deleting the node or deleting the value from the leaf node. So I can delete it directly without any problem. So I can delete this value. So here I am directly deleting it. So I cross mark it. Now next, delete 170. Delete 170. So 170, just look at the position of 170. So 170 is greater than 115. I go to right side. Right side is 120 and 200. So 170 less than 200. So I go to the left child of 200. Left child 200 is this leaf node. This leaf node contains your 170. But how many keys are present? It contains 2 keys. And what is the minimum keys that should be present in each node? That is also 2. So I cannot directly delete it. I will take the help of right sibling. You are going to take the right sibling. You need to take the borrow. So what is the meaning of that one? You take the borrow. So if you are going to take the borrow from the right sibling, how the tree look like? So if you look at here, so I want to delete the next value 170. 170 is present here, so it contains minimum key. So I'll take the help of the right sibling, borrow from the right sibling. So 220 goes to 200 place. So 220 goes to here. So remaining values are 230 and 240. So 220 goes to the place of 200 and 200 comes to the place of 170. So 170 deleted. So remaining values are 200 and 180. And the remaining keys will be as it is. So I am not writing here. You just do one thing, copy and paste. Alright, so the remaining values will be copied to here. Alright, so there is no issue. Now, so this is the way we have deleted 170. Next is delete the 220. And in your internal node contains minimum key size. So minimum key size for order 5 is here 2. So we cannot delete here 220 directly or I cannot take the help of your left child and the right child, because both are having your minimum key size. So in that case I will take your rule number 3, case 3, for deletion of internal node. If the internal node that will be deleted contains minimum key size, then we will go for the merging with the sibling through the parents. Here 220 sibling node is containing 104 and 110, so that will merge through your parent 115. So after merging, the tree looks like this way. So here we have merged 115 and the sibling value 104 and 110, and the tree looks like this way, and 220 is deleted from the given B tree. So this is the final B tree after deletion of 3 elements.